All right, everyone. Hey there, Dr. J here. And in this video, we're going to continue talking about weather and weather services, METARs and tasks. And this is maybe a little bit of a throwback back in the day when they didn't have, internet available on your phone all the time with weather reports and things. These are and were services that you can use, that you can access to get you information about weather at different places. And these are specifically going to be for airports. And this is going to be covered in the PHAC Chapter 13 and the Remote Pilot SUAS Study Guide Chapter 3A. And there's a couple advisory circulars there that you can see listed, so you can check those out as well. So as we've talked about, we need to know actual information about the weather and how it impacts aircraft and how, what conditions should we fly in, what conditions should we not fly in. But we also need to know where to get information about either the current weather if we're heading outside to go on a mission, or future weather potentially, forecasting out what can we fly in the next 5 days, for example. And this is where these two things, TAFs and METARs, are going to come into play. You can kind of see a little outline here about what we'll go through. METARs and TAFs are essentially the same thing, at least in terms of the language. Both of these things are going to essentially be like a code almost that you'll need to be able to decipher in order to understand what it's saying. And that code, once you can read it, works for both the TAF and the METAR. So that's the good news. Now, of course, the bad news is that you have to understand the code, but that's all right. We'll work through how to decipher that code, and it's not too bad once you sort of figure out the general patterns. Weather information is available both as reports, which are for current weather, and as forecasts, and there are a few different places to get this weather information. One place is aviationweather.gov, so there's going to be some information there that is going to not necessarily be given in a normal weather report. For example, the pressure at a particular location, the air pressure. The dew point might be another example. So there's going to be some information here that's specific to aviation, which normal weather reports are not going to give you. So that's why these are valuable, in addition to the fact that, they're sort of historical things, and you have to know about these to pass the Part 107 exam. So as I mentioned, you can go to aviationweather.gov. You can go to various apps, including the Aloft app. There's a flight service station, 1-800-WX-BRIEF, where you can talk to an actual person. So the METARs and the TAFs we'll see as well is a written weather service. They are a standard format used globally, so no matter where you are around the world, they will use this same format. Again, it's kind of a code that you have to interpret, and they're issued hourly unless there's really significant change, such as a storm front moving through. And you can find these online, aviationweather.gov/METAR. You can pull up an actual METAR for any airport in the world and get the information that way. So again, this is really going to be primarily for the area around airports, but chances are if you're going to an area, there's an airport not too far away, and so then you can use that to kind of get an idea about the weather where you're going to be. All right, here is what a METAR looks like. And again, as you can see, it's sort of written as a code. You see a bunch of letters and numbers, and they're separated by spaces. Each thing which is separated by a space is one individual thing. So KSDL, for example, would be 1 bit, and then 2000251Z, that would be another section of the code. And so you can interpret these individually. So let's talk about what this means. Let's learn to read the code, interpret the code. The first part here is the airport identifier, and that's pretty much always the case. The airport identifier will come first. All US airports are going to start with a K. And so you would just have to look up what is the identifier for the airport that you're interested in. The next bit is going to give you the day of the month. So these are, again, generally speaking, these are hourly forecasts, and it's going to give you the time of day of that, or sorry, not forecast. Right now, we're just talking about current conditions. So this is going to give you the time of day when the current conditions, the conditions that it's about to list out, are active. So it's 20th day of the month, and then 0251 is Zulu time of day, 0251. So that would be 2:51 UTC time, 2:51 a.m. UTC time. UTC time is universal time, or Zulu time, as it's called here. So this is the time in Greenwich, England. This would be the time if you were at the 0-degree longitude on Earth. The next little piece of information here is the wind direction and speed. So here we are, 230 is the wind direction in degrees clockwise from true north. So we talked about, in this class, we've talked about the difference between geomagnetic north and the Earth's true North Pole. So this is relative to true north. The wind direction is counterclockwise in degrees. And then the next piece of information here is the wind speed in knots. So we've got 03 KT stands for knots. Here's some other examples of wind speed. 16 GT, gusting 2 is GT. So 16 knots gusting to 22 knots. And then VRB would be variable direction. And then 05 would be, here we are, variable direction, 05 knots gusting to 17 knots. The next section here is given our visibility. So SM would be statute miles. So that's how we know this is visibility. 10 statute miles, visibility. Clear, no clouds in the sky. Other examples might include this dash RA. That means light rain. RA by itself would be rain. OBC stands for overcast, and 090 would be 9,000 feet. So as you notice, the numbers here are always given for heights, for elevations. The numbers are going to be given in units of 100 feet. So 090 would be 9,000 feet. This next section here is for temperature and dew point. So we are at 1 degree Celsius. Temperature is also always in Celsius. M means minus, so minus 12 is the dew point. So temperature is the first part, dew point is the second part. And of course, this is important information because if the temperature and the dew point are the same, if the dew point was, for example, 0.1 and the temperature was also 0.1, then that would mean either you've got fog or precipitation happening, one of the two things. The air is saturated. Our next section is our altimeter setting. So that's 30.34 inches of mercury. So these are kind of funny reports in that they use Celsius, but then they use inches of mercury to report the pressure. So a little bit strange, but that's what that is. This is outside pressure at the airport, and it's reported as if it were at sea level. So remember, we had a whole conversation about pressure and pressure levels, how pressure changes as you go up in altitude. And so what you have to do if you want to know the actual pressure at the airport is use the elevation of the airport, which would be reported with that airport's information. If you look it up, you would have to use that to convert it to measured pressure. So this has actually already been back calculated to pressure at sea level if you're at that particular airport. And the reason that this is the case is because airplane pilots, when they're flying up in the sky, they're not at the elevation that the airport is. They know their information. They know their pressure above sea level. And so the pressure reading that an airplane pilot has is pressure above sea level. And so then when they have this pressure, then that's what they're using to compare to what they have on their pressure gauges. So that's why that's the case. But it is a little bit confusing. Just keep in mind, this is pressure at sea level at this location. RMK stands for remarks. And so here we just have a couple of kind of random remarks. A02 is the type of station recording the weather conditions. In this case, a precipitation discriminatory station. So this station can discriminate between snow and rain. And then SLP is sea level pressure. So now they're reporting the pressure in hectopascals, which is what would make sense if you were going to use temperature of Celsius. Anyways, here's the sea level pressure in hectopascals given as SLP 285. And then one final remark that's here is that the temperature, this is just a remark giving the temperature with an additional digit of precision. The $sign actually is not a typo. It means that the sensor requires maintenance. And so use this information with caution. There might be some problems with this information. All right, so that's one example. Let's just go through another example. By the time we do a couple of these, you guys will be onto it and you'll have it all figured out. There's our airport identifier, KSEA. And there's the time and date of the not forecast, but the current conditions. So the 20th day of the month, 03:53 Zulu time. Seattle Airport, there's our reporting time. There's our wind speed and direction. So 230 degrees clockwise from true north, 5 knots wind, 10 statute miles visibility. There's our OVC. That's our overcast sky at 090. That's 9,000 feet. Oh, so the sky is overcast at 9,000 feet. And then we've got our temperature and dew point. So 11 degree temperature, 11 degrees Celsius, and a dew point of 4 degrees Celsius. Oh, and we've also got our altimeter reading there at 29.63 inches of mercury. We also see one of these remarks. We've got that same kind of sensor. There's the sea level pressure in hectopascals. And then there's the same kind of additional digit of precision with the temperature reading. All right, we're barging through these things. If I'm going too fast for you, just go ahead and pause the video and take a look at these and try to work out what each piece of the code is for yourself, because this is important. You'll need to be able to interpret these codes. Okay, so let's go through this one. By now, this should be old hat. We've got our KACV, excuse me. This is some airport on the West Coast. I don't know which one it is. We've got information being reported at that particular time, 20th of the month, 3:53 Zulu time. Auto means that's something new. It means we have an automatically generated report. Then we've got our wind speed and direction. Again, we've got our visibility. Now, if you notice, this visibility is different than what we had before. It's 1 1/4 statute miles. So this is actually one piece of information here. And that space is a little confusing because normally we think about the space as separating things. In this case, it's separated so that we're able to read that this is 1 1/4. So 1 1/4 statute mile visibility. R, in this case, this is kind of a different one and a bit unusual to see, but this basically stands for runway. So this is runway 32, has visibility from 4,000 feet to more than 6,000 feet. We just have a few thousand feet of visibility at runway 32. So probably there are multiple runways at this airport, and this particular runway has a somewhat lower visibility than the general visibility in the area. There's our dash RA, that means light rain and mist. Oh, sorry, light rain is dash RA, and then BR is mist. Remember, the elevations are reported in units of hundreds of feet. So this is 003, 300 feet above ground level. There's our temperature and dew point. And look at that, they're the same. Temperature and dew point are the same, which means that we're going to have precipitation or fog or both. And in this case, we actually have both. And the best way to kind of get better at this is just to do some practice. And so here's a link to a website where you can copy in METARs and you can decode them and sort of get some practice at interpreting these.